Okay, Rhonda, Robin, Brittany, Michael, Montana, Rebecca, Andy, here, Hunter, Tanner, Aniston, Amy, Kevin, Carter, Logan. Well, today we're going to start the first lecture, and we have a lab. But our lab on today should be really short. Well, like what I said, before we're going to start to go to the real soil fertility, I'm going to review the soil information and so on. I hope that nobody has a problem to get the lecture notes from the tomorrow. Can I ask you, who has a problem to get the lecture notes from the Moodle? Everyone's fine? It's okay? No problem? Okay. If you have any problem to get the lecture notes, please let me know. If it is not, that's great. Okay, first of all, like what we mentioned today, definition. Okay, soil definition is really important. That is about the first step to study about the soil fertility and soil science. So its definition. Soil is a dynamic natural body composed of minerals, organic material, air, and water, which acts on and is acted on by living organisms in a thin layer covering the Earth's surface. Please keep in your mind this definition. Don't forget it. I like to ask you. Okay? I like to ask you. I promise you I make a question in the quiz or exam. Okay? Or both. That is the first step to understand the soil and soil fertility. So please don't forget it. Keep in your mind about the soil definition. That is a correct soil definition. If I'm too fast, please let me know. Okay. And here are the 4 plant growths. Well, soil is really useful material for our life. However, let's talk about that 4 plant growths. Soil able to provide water, air, nutrients, temperature, and structure for plant. And for plant. Soil able to support to the what infrastructure, like when you're gonna build a house, you need a soil. When you're gonna try to get some, how can I say that, source mineral, we need a soil. And we are able to grow the plant with it using the soil. Like what I said, W, water, A, air, nutrients, and E is temperature and structure for support. So we simply say that once. I think you are familiar with that word once because we talked about it last time about the soil and the soil science class. Those conditions that favor plant growth are also need for other uses. So plants going to be required that the minerals, the nutrients, about 18 essential nutrients needed for the plant growth. Soil supply 15 of these for nutrients to be taken in by the plant. It must be dissolved. That is one of the key. What is the main focus? our main reason why we started the soil fertility. Because soil gonna able to support that. Really important because most of the essential nutrients to grow the plant. That's why, so in the soil fertility, we're gonna study about that, what kind of nutrients and how we're gonna prepare those nutrients to grow the plant. That is soil fertility. About the 15 out of the 18 essential nutrients can be supported. Carbon, hydrogen, and oxygen, we call the CHO. Those ones commonly come from the water and air. It means soil does not really support that CHO. Other one, nitrogen, phosphorus, potassium, sulfur, magnesium. Those kinds of essential nutrients, soil is going to support it. In the soil fertility, we're going to talk about it. And about the soil basic information, there are the 4 basic components: organic matter, mineral, air, and water. So commonly, we are able to find it in those kinds of components: air, water, mineral, and organic material in a soil. And the average percentage of air in a soil is 25%, water is 25% too, and solid, okay, that one is 50% in a soil. Why? Because organic material is solid, mineral solid. So if we talk about the solid in the soil, we call that 50% of solid. However, if we're going to talk about mineral in the soil, we call that 45%. And 5% is organic material. Well, these kind of percentages, it depends on the location. Like desert area, there is a lack of the water. That's why in the soil there is less than 25% water in the desert area. However, more than 25% of the air in the soil and the desert area. How about the wetland area, like the loss of the water area? There is an area. Those areas has a more or higher percent of the water with a less percent of the air. And the organic matter percentage, this one is also depends on the location. Louisiana case is about the 1 to the 2% of organic matter in the Louisiana. It's lower than average percentage. However, Minnesota or North or South Dakota, those areas has a higher percent than average percent. For example, the 35 to the 40% of organic material we are able to find in those areas. Okay. And the mineral is 45% commonly. So total is 100%. Also, this one, you should know about that. And the soil going to be consist of the lots of horizon. And then combining the horizon, we call the soil profile. Commonly, there is a 5 soil horizon. O horizon, A horizon, E horizon, B horizon, and C horizon. O horizon is what accumulates organic matter, but these organic matter is not really decayed. Just organic matter is the waste stuff. Like a raw kill of animal body, dead body, it can be organic matter. If you drop that the paper, organic matter. Okay. Plants drop that the dead leaves on the ground, organic matter. Okay. However, those organic matter is fully decayed and then form that the layer we call the A horizon. So A horizon simple definition is accumulate organic matter. That organic matter is fully decayed organic matter. Also we call that compost. So compost case is one of the types of organic matter, and then we don't know what was it before because the waste stuff or organic matter already broken down. Okay? fully broken down. And then they have a black color. Why? Because when they broken down, they release carbon. And carbon natural color is black. That's why commonly organic matter has a black color. So commonly A horizon has a dark color or darker than other horizons. And then E horizon is going to be occurred by eluviation. Please watch out at the spell. Because it's not easy for me to pronounce between the eluviation and illuviation. I don't know. But when you watch the spell, eluviation or alluviation, I don't know. But the spell, look at it. The first letter of alluviation is letter E. That's why we call it E horizon. How E horizon going to be occurred or formed today? Well, when the rain and then water going to be start to tour from the high elevation to the low elevation through the soil profile. So when the water moves through the soil profile, water is going to carry out some small particle size with organic matter and mineral. Like a clay particle size or mineral, they can be carried by water. So water can be moved, go deeper with those clay and what? Mineral from the A horizon. That's why a part of the A horizon lost that what? Clay particle and mineral. So a part A horizon lost it clay and mineral by water. And the part, lost it part by water in the A horizon, we call the E horizon. And then the E horizon color is much lighter than the A horizon. And after that, the carried out by water going to be accumulating some area in the soil profile. Because when the water moves from the high elevation to the low elevation, the water losing the power. So when the water loses the power, they cannot carry that the clay particle or nutrients anymore. So they're going to drop it because they don't have a power. That's why some of the part area, water gonna drop that clay particle and mineral and accumulate the area, clay particle and mineral. Okay, the area we call that the B horizon. B horizon, B as one. And then the accumulation is called the eluviation, letter I. Eluviation. And then C horizon is unconsolidated material. One of the simple words for the C horizon we call the parents material. You come from the parents. You cannot show up on the earth by yourself. If you show up by yourself, we call that you are an alien. You are not from the earth. Okay. So soil also gonna be formed today from that the parents, like we call that parents material. The parents material mainly come from the rock. The rock, we call that unconsolidated rock, which is gonna be broken down easily by weather or chemical reaction. So C horizon is unconsolidated material like a rock. So B horizon is really weird. Why? Because this one can be formed from the top, okay, by eluviation. Okay, water carry out and then drop it at the one of the place. We call that B horizon. Also, C horizon can be broken down. Okay, rock will be break, and then the soil, like the rock piece, is getting smaller. And then smaller or broken piece of rock will accumulate to form the B horizon too. So B horizon can be formed from the eluviation, ILL, and from the breaking the C horizon to form the B horizon. That's why commonly B horizon is larger or bigger than the ABC horizon. I mean, AB horizon, AD horizon, sorry about that. And then each horizon has their own characteristic. Okay, they have their own characteristic. And then we're gonna put that as some small or lowercase letter to express that each horizon characteristic. So here the lowercase letter symbol to subordinate distinctions within master horizon. If we see that the plowed layer, we're gonna add that the lowercase p after the master horizon. Master horizon O A E B C. So if you see the plowed layer in the A horizon, we call that the A horizon is AP. Okay. Watch out that the uppercase and lowercase. You must put that the lowercase if you're gonna add that P letter, for example. And if you see the accumulation of silicate clay, we're gonna add that the T letter after master horizon. Master horizon always uppercase. Yeah. And if you see that blade or bottle region in the horizon, we're gonna add a G. If we find that the slick side, we're gonna put the double S. If you see the high density area in the solar horizon, we put the X, the letter X. And if you see the many of the carbonate in the horizon, we're gonna add the K. If we see the gypsum in the horizon, we add the letter Y. And if we found that soluble salt in the horizon, we add the letter Z. Z as zoo. That is common lowercase letter symbol to subordinate distinction with the master horizon. However, we have more than that. This is a table in figures with the table to show you about all kinds of lowercase letter symbol. So at least you need to remember that this one, at least. And please, after you remember the previous one, please remember that this one. You are able to find in a photo of this electronic version of this table. If you cannot, also I try to prepare the hard copy for you. Okay? I try to prepare the hard copy for you. So please give me a time, then I'm gonna prepare for that. But at least you need to prepare. You remember that this one, at least. And can I go? Okay. And in the soil texture means size distribution or soil separate. It depends on the percentage of soil particle. Each soil particle has their own size, and then we're gonna organize it. If soil particle size is between the 2 and 0.05 millimeter in diameter, watch out at the unit. Okay, they're using the millimeter. Okay? We call the sand particle. If soil particle size between the 0.05 and 0.002 millimeter, we call that silt. If soil particle size less than 0.002 millimeter, we call that the clay particle size. So when you see that the right side from your view on the screen, you can see that the chart, that is a grain of rocks, a small piece of rock. And then this is sand particle, and silt is like a dot. Okay? Clay is invisible, really tiny. So just in case, if you see the companies, have you tried to use the baking powder, baking soda? That kind of size is like a silk size. You are really smooth. Clay particle size much smaller than that one, and then you can see that the one clay particle size. That's why we're going to use the electronic microscope to see that clay particle size. And the soil texture That is a small size means a large surface area per unit of weight. It means soil is really important. One of the reasons soil able to support the nutrients. Okay. So to support the nutrients for the growing the plant, soil gonna keep the nutrients. Where they're gonna keep the nutrients? Well, commonly they are able to hold the nutrients for the soil particle surface area. Each soil particle surface, each soil has their own particle surface area, and then which one has a large soil particle surface area? Well, smaller particle has a total number of smaller particle surface area is larger than large soil particle. Simple concept is sand. Okay, sand case they have about the 0.1 square meter per 1 gram. It means 1 gram of sand has a 0.1 meter square surface area. It means simple concept is what? Parking lot. Okay. Think about the parking lot. Large parking lot able to keep the large car, many cars. Small parking lot keep the small number of cars. Okay. Surface area. Large surface area has a large, many of the nutrients. Small surface area has a what? Small amounts of nutrients. And people think that, oh, small particle size has a small surface area, and they're gonna be able to keep the small amounts of nutrients. Yes, you're right. If you think that one particle size or one particle, however, we're gonna think like that one 1 gram. In the 1 gram, how many sand in there? In the 1 gram of silt, how many silt? In the 1 gram of clay, how many clay particles? Clay particle is huge amounts in the 1 gram, and then each clay particle has their own surface area. That's why when we calculate the total amounts of the clay particle surface area, and then we are able to see that 1,000 meters square surface area we are able to see in the 1 grams of soil particle. In the 1 grams of soil particle. It means soil particle has much more space to keep the more nutrients. That's why soil, like a clay, is a pretty good source to keep that enough nutrients. However, everything has a risk. Soil, in the clay case, they're not able to keep that more and more nutrients because they have a large surface area. Problem, they're gonna also hold it water. Okay. So among the clay particle, there is an empty spot we call the soil pore space. And the soil pore space is really tiny among the clay particle. And the small size of pore space is able to trap the water molecule, unfortunately. And then there is a lack of oxygen or gas or air, we call that. So if you're going to grow that plant in the clay with water, and the plant does not have enough oxygen for the respiration, and the root parts die because they cannot run that respiration by a lack of oxygen in the clay. In the low life. Okay. That's why in the farm, lots of producers, they're gonna try to keep the silt types of soil, or we call the loamy types. So the loamy types of soil, well, they have a less surface area than the clay, but still they have enough area to keep the nutrients. or they have a more area, surface area than the sand. And they are able to keep that enough oxygen to run that respiration for the plant root. So they like to grow that the plant or crop at the field. What types of condition? Silt types of condition or loamy types of condition of soil. They're gonna keep it instead of clay types. Even clay has a huge area to keep the largest amounts of nutrients. So please keep that about this chart. Please keep in your mind about the sand, silt, and clay particle size and surface area. Please keep in your mind. 1,000 meters square in the 1 gram of clay. Bigger than or larger than this room or what? Auditorium. And the soil texture class. Each soil has a different percentage of the sand and silt clay. That's why we're gonna categorize it. Okay? We're gonna categorize that the soil texture by using that the percent of the silt, sand, and clay. So what kind of a tool we're gonna use it to classify that the soil texture class? We use that the soil texture triangle. Okay? We use that the soil texture triangle. When I ask you, well, what kind of tool or what tools we use it to classify that the soil texture, and then you must say soil texture triangle at least. If you say soil triangle, I give you wrong. I said wrong. If you say texture triangle, also I say wrong. At least you must say soil texture triangle. Okay? We use it. If you like, you are able to add that USDA soil texture triangle. It's okay because USDA cannot made this triangle. So we're gonna use this soil texture triangle to classify the soil texture classes. And in the soil texture triangle, we are able to see 12 soil texture triangle. And how can we use it? Well, here's an example. If you see that when we're gonna collect the soil sample, and then we're gonna analyze it, how much percent of silt, clay, and sand of the soil sample, and then the 40% of silt, 20% of clay, and 40% of the sand is found in the soil sample. And then we use this percentage of each to classify the soil texture. How can you use it? Well, first of all, you should remember that which line is for the which, because this side of the soil texture triangle is a percent of clay. This side is a percent of silt, and at the bottom of the triangle is a percent of sand. And then last of the line. So which line or which? Well, before I start this, I want to tell you, please remember that time clock or clockwise, okay? Clockwise. Think about the clockwise. Keep in your mind clockwise. So this was loamy. How? First, this line is clay line. This line is clay line. From here to here, clay line. So 0% clay, 10% clay, 20% clay, 40% clay, 50, 60, 70, 80, 90, 100. And silt case is line. Okay. From there, 0% silt, 10% silt, 20% silt, 30% silt, 40% silt. So which line? This line for silt line. And last one, sand. Sand is that the kind of line, okay, from the bottom to the left. So 0% sand, 10% sand, 20% sand, 30% sand, 40% sand. Okay, so based on that information, oh, sorry about that. Silt, in this line, 0, 10, 20, 30, 40. This line and this line. Please remember that this line clay 20%, 0%, 10%, 40%. This one is 40% silt, 20% double clay. So should be in here. Sand is 40%. Sand. And 0, 10, 20, 30, 40. So matching of these three lines in here in this series. Matching points among the three lines is 0. That's why we call that a sample which has a 40% silt, 20% clay, and 40% sand. Matching points line of silt and clay in here is a long area. That's why we call that the soil sample is long. The sample is long. So clockwise. Sand, clay, silt. Line come from sand. Line come from clay side. Line come from silt side. Okay. So if you remember the which line for the which, just draw the line at each percentage of the silt, clay, and loam. And then find the matching point in the area. Please keep in your mind. And soil structure, and then other soil characteristics. Structure means grouping or arrangements of soil particles, sand, silt, clay, and organic matter into aggregate. So what is an aggregate? Well, simple means of aggregate is of a grouping or chunk of the soil particle. So soil aggregation is the formation of soil structure when soil particles loosely or strongly stick together into pads. And organic matter, like a humus or compost and soil clay, are important agents of soil aggregation because organic matter and clay act like a glue. Okay, act like a glue. So soil particles can be grouped together. Okay. So soil pad, what is a pad? Pad is a single unit of soil structure. Pad shapes include granular, flaky, blocky, and prismatic. So simple concept is this one. We're gonna collect the soil sample from the soil, like an aggregate, and then we're gonna tap it. And we're gonna tap that the soil aggregate or aggregate. When the break in the soil aggregate, we are able to see that the broken pattern. Okay? Broken pattern. Whenever we break the soil, and then the soil sample has what broken piece of the soil sample has the shape of a blocky, angular blocky, or rectangular blocky, okay, or prismatic types. We're gonna see that kind of pattern, and then we could, oh, that is a blocky or angular blocky or prismatic blocky or prismatic types. Some things have a plate shape whenever we break it. Okay. So we call them platy types. Some aggregate, when you break it, there's no shape. We call that we call that massy. Okay. Like the sand stuff. So we're gonna see that kind of broken pattern. Okay, we call that soil structure. And the soil structure, why we're gonna concern about the soil structure? Because the soil structure is able to affect water movement air movements and plant root growth, okay? Root growth and heat transfer. Okay? Commonly, they are able to affect that those stuff, but more than that, their soil structure able to affect it. But that is common and major things how soil structure able to affect it. That's why we need to know about the soil structure. And the soil structure, well, we talk about the granular type, flaky type, lumpy type, and prismatic types. And which part we are able to find that the granular types easily, or which horizon has the granular type. Commonly, we are able to find that the granular type is O horizon and A horizon, like an organic matter area. So granular is like a cookie shape. So if you find that the lots of organic matter, then commonly there is a granular type. If you see the granular type soil structure, that means there is a lots of organic matter. So you can see that or tracking that. Where can you find that organic matter? And then platy types, we are able to find that the plate shape of a soil structure, we call the platy types in the E horizon. In the E horizon, or S the E horizon, we are able to find it. Blocky and prismatic, okay, prism-like or prismatic, we call them also. We are able to find the blocky types and prismatic in the B horizon, easily, commonly B horizon. And then on the in the arid area, okay, in the arid area, we are able to find that the prismatic more. In the humid area, we are able to find that the more blocky types. So desert area has a more prismatic, and the wetland area has a more blocky types. It means Louisiana has a more blocky types. And then the structureless or massive, in that case, when we break it, we cannot find that. I'm sorry about that. We cannot find that, or pattern of broken pattern. We cannot find that the broken pattern easily. In that case, we call that structureless or massive. So each horizon commonly has a different type of soil structure. And then commonly the generally blocky types is upper B horizon. Prism-like is lower B horizon. We are able to find it. Because prism-like is a rectangular shape, and then when the rectangular breaking down to form the blocky. That's why commonly blocky going to be upper B horizon. Prismatic or prism-like is lower B horizon. However, if blocky type can be found in the wetland, prismatic in the dryland. And each location has a different amount of different types of soil profile. Some area has a more various types of the horizon. Some area has only A, B, C horizon. For example, the desert area case A, B, C. That's it. Desert area has just A, B, C. With the thin A horizon, thick B horizon, and C horizon. There's no O horizon, no E horizon. That's the desert area. Why they cannot find that the E horizon in the desert area? Because, first of all, lack of water. How E horizon will be formed by E horizon can be formed by elevation. Water carry out the clay and mineral from the A horizon. So a part of A horizon lost the clay and mineral. That part we call that the E horizon. But first, desert area, they're just lack of water, not enough water to run that elevation. Okay. There is a thin air rise, it means there is not enough organic matter. Okay. So even there is a water which can able to move from the high elevation to the low elevation through the soil profile, there is a lot, not enough air, right? Not enough light. That's why there's no heat right unfortunately. However, if you see that the temperate deciduous soil, temperate deciduous soil, you are able to see O horizon, A horizon, E horizon, B horizon, C horizon. And then here, grassland, okay, grassland soil, like prairie land area, like our area. They has a lots of the air right, you can thick of air right. How? Because lots of grass, when they die, they drop the large amounts of organic matter, and the large amounts of organic matter can be decayed quickly to form the air right. Well, probably there's a grassland that has enough water, so air rise is going to be occurred in it. Not really. Why? Because whenever they have rain or water precipitation, the water source, when the water is going to be trying to move to the deeper area from the high elevation through the soil profile. However, lots of the grass, they're going to take it up with the water for their life. So water do not have enough power to carry out from the high A horizon to the B horizon, unfortunately, because lots of grass with a high vegetation level, suck it up or take up the water before water will carry out. That's why in the grassland soil, there is a thick of A horizon and there is no E horizon, unfortunately. However, if you see that the trees area, the forest area, you are able to see E horizon. Why? Because there's organic matter and there's water, but the water does not lose the power because what? There is a tree instead of grass. So water can be poured from the high elevation to the low elevation, and also trees, they're gonna develop their root system in the much deeper area. So trees gonna take it up the water from the soil, and the upper area of the water gonna be pulled down to the deeper soil profile by trees' root. So water has or keep their power to move the nutrients from and the clay from the A horizon. That's why you are able to see that the E horizon in the two trees area. Well, also these kinds of figures you are able to find in that where more. And soil formation, how soil able to form the dirt? Well, commonly there is a 4 step. There is nothing on the rock. There is nothing on the rock. We call the bedrock. Bedrock, just the rock. And then the rock will be broken down by weather. The rock will be broken down by weather. And sometimes birds fly and they put it on the ground. And sometimes wind is gonna carry that with the waste stuff, and then blow up the waste stuff, and then drop in on the rock area. Okay, which ones can be organic matter? And keep going to breaking down bad rock or consolidated rock, and then they're gonna broken piece of rock and accumulate organic matter, and then they're able to form that A horizon and C horizon in that what sort of file. First, they just have rock. Rock is rock, R and C, and just rock, broken piece to form that small piece of the particle, and then you are able to see A, B, C horizon. And then we call that this whole thing is what? Soil profile. So commonly there is a 4 step to form that what? Soil. bedrock begins to disintegrate. Second is organic material facilitate in disintegration. And the horizon will be formed with it in the third step. And final step is develop the soil, support the thick vegetation. And then they're going to keep going on to get the more deeper, more thinner, or form that erosion by condition, or weather condition, or environment conditions. Well, these kind of soil formations took a long time. Okay? This time is not really short. In the 10 years, soil cannot form it from the rock. Much longer, really long, really long. So there is a soil forming factor. What is the main factor to form the soil? There is 5 soil forming factor. Please keep in your mind. I like to ask you. Okay. Soil forming factor. Never forget it. Climate, terrace material, biota, topography, and time. Okay. Please keep in your mind those 5 soil forming factor. In the 5 soil forming factor, which one is the most important factor? That is a climate. Okay. The most important factor to the soil formation, climate. Never forget. Because climate, like precipitation, like water, rainfall, they're gonna able to breaking down that what? Rock. And then those climate able to deliver what? We're getting better. That's why. So they're able to form that. And the broken piece, like what is the main? So it's come from that what? Terrace material. That's why rock is also like a terrace material also main factor. Well, also another thing is the soil characteristic, because it depends on the terrace material. Like you have a blonde hair, you have a curly hair, you have a black hair. But gray hair, for my case, is not from the main nature because my parents got it just nature. When I get old, I have a gray hair. It's a different story. But you have a black hair, curly hairstyle, or straight hair, or blonde hair, or your eye color, black eye color, brown eye color. These kind of characteristics come from where? From your parents. Okay, from your parents. Soil is the same thing. Some soil has a lots of carbonate. Some soil has a lots of the how can I say that, gypsum. Some soil has a lots of sodium. Some soil has a lots of diamond. Some soil has a lots of chocolate. Why? Because they come from the rock, and then the rock already had lots of calcium carbonate. Already had lots of gypsum, and then the rock broken down. The gypsum stayed there. The rock is broken down, which has lots of sodium. Yes, there is lots of sodium in the soil. So terrace material is one of the source to form the soil characteristics. And biota, like a living organism, living organism like a plant, like a trees or grass or a bird. Many of them they're gonna able to affect that soil of forming, forming the soil. For example, some of the soil can be upside down by a what? By a small animal, like ants. When the ants gonna develop their own nest, we call it colony, they're gonna dig it, and then when they dig it, they dig the soil and it comes out from the deeper area to the soil surface. That's why. And topography is also able to affect the forming the soil because topography simple concept is slope, deep slope or shallow. If there is deep slope or shallow, and then a soil particle can be moved easily. And then accumulate some area. If the soil slope is really 0% like flat, the soil particle cannot move, it just stay there. So topography able to affect that what? Soil forming the soil. Time required long time required. Short time, not really. You cannot form the soil in a short time. In the 100 years, possibly, yeah, possibly, but not really. And soil forming progress, the simple soil forming progress is breaks, transfer, and deposit. Like a rock going to be broken down, and broken piece of rock will be accumulated in some lower area because by gravity, the soil particle can be moved from the high elevation to the lower elevation. Everything is moved from the high elevation to the lower elevation by gravity. Okay? That's why broken piece of rock will be moved by gravity and then accumulate in the lowest area to form the soil. And there's the two kinds of condition: physical condition and chemical condition. Physical condition of a mineral is disintegration. The particle size will be broken down by crushing. Okay? When the broken piece of rock, the crushing on some other broken piece of rock, and then they're gonna get broken down. And then the broken piece, okay, will be getting smaller and smaller, and then the texture, the feeling is really fine, it's smooth. Or bigger size is rough. If you touch the sand, you will feel rough. If you touch the what? Baking soda or foundation, woman's foundation for the skin, that was also certain types. When you feel it, it's really smooth. Why you feel smooth? Because each foundation particle size is really tiny. That's why you feel smooth. So those kinds of the rock getting smaller and smaller, or break and break by physical impact. Rolling the rock and they hit another rock. However, chemical characteristic of a mineral is decomposition, like a chemical reaction. It means there is a commonly chemical reaction going to be occurring in the nature, and then they're going to be able to affect the soil characteristic. Like a mineral hardness or material cementation. It means they're going to form it or they're going to be really not hard because they can be broken down easily by biochemical reaction. Okay. And how the various kinds of appearance material are formed, they transport and deposit. How can they form the soil profile? First of all, the rock going to be broken down, and the broken piece of rock will be moved and be transported by water, by gravity, by ice movements, and by a wind. So, broken piece of rock, small soil particles. I said small, but some broken piece of rock size, my hand size or tiny size. Okay? So, broken piece of soil going to be moved by water, gravity, ice, and wind in their each of them. And then they're going to deposit in the lake, deposit in the stream, deposit in the ocean. Well, you are able to see the fuzzy stuff, but don't be scared because I uploaded in the mode of this electrical version. Also, I try to prepare the hard copy handout for you. Okay? Hard copy handout for you. This one. So don't be scared. Oh, I cannot read really well. Please look at that or check out that tomorrow teaching material site. And please give me a couple of days. I'm going to prepare the hard copy paper for this one too. So when the soil appearance material, the soil particle, broken piece of a soil particle moved by water and deposited in the lake, we call that lacustrine. Okay, lacustrine. If the water carried that broken piece of a soil particle and deposited by a stream, we call it alluvial. If they're gonna broken down and then deposit the soil particle in the ocean, we call them marine. Okay? we have one of the types of the army, the marine, so that is different. And then broken piece of a particle will be moved by gravity, and then deposit lowest area, we call that colluvial. Okay, colluvial, a child, colluvial, and here's alluvial by a stream. And then the broken piece of rock will be moved by ice and deposited in the ice. We call it hill or moraine. Okay, I hope that my pronunciation is correct, but the moraine. I hope so, it's going to be correct. And then they're going to transport by ice. However, melting ice is going to be water. Water is going to be deposited. Okay? The soil particle is deposited by water. We call the outwards, lacustrine, alluvial marine. Lacustrine, alluvial marine. And then the wind carry out the soil particle and then deposit the soil particle by a wind. Eolite, we call the eolite, like a dune, G-U-N-E, sand dune. We are able to see these kinds of the eolite easily in the desert area. So don't be scared, it's going to be fuzzy, not really clear, it's okay. I will prepare the hard copy paper. So here is the text version trying to show you what you must know about that is. By water, soil particle gonna transport by water, and then accumulate by water. Well, first of all, the soil particle can be moved by gravity. Why? Because water gonna be moved by gravity too. Water moved by gravity from that high elevation to the low elevation. So material that accumulate at the foot of a steep slope, we call the gravity, and alluvium, okay, alluvium or alluvium is a material transformed and deposited by a river and stream. We call the alluvium or like stream. And floodplain, okay, floodplain. Floodplain is occurred in the slow river. Okay, there is a river, move the fast, or there is a river, move the slowly. When the river gonna move slowly, they're gonna drop the sediment. Okay, and then accumulate the sediments in some area that we call the river bank, and then those floodplain. And alluvial bed and delta deposit. This one case is what? When the water, what is the final destination? Water is the ocean. Okay. So when they're gonna close to the coastline, water speed is gonna be a little slow down because they're gonna meet the open space ocean. Okay. When the water is gonna meet the ocean, they say, whoa, it's really wide and the huge area, and that water gonna drop their power when they arrive in the final destination ocean. Simple concept, you are really nervous when you're gonna tour or trip by a train or airplane. Okay? And when we arrive in the final destination, oh, finally I arrived there. So, simple concept, water gonna be moved by a river, by a stream, and then they're gonna carry the glass of sediments. However, when they meet the open space, they're gonna spread out their energy. Okay? That means they lost the energy to carry their sediments. So when they meet the huge open space area, the water gonna drop with the nutrients or soil particles. So when the water gonna meet that sea, okay, like sea, S-E-A, or the ocean, the coastline, they're gonna drop it, and then there's the sediments gonna be accumulated. We call that delta deposit. We call that delta deposit. When they meet that really huge open space, like an ocean. However, when they see that the open space, but there's ground, they do not arrive into their final destination, like ocean, yet. But they see that really huge open space, like a flat area. You mean water going to be moving, and then they see that open space, so they can spread it. Water spread it. When the water spreads it, they lose the power, so they drop it. We call it alluvial fan. We call it alluvial fan. That is spread wide and open area. So alluvial fan and delta deposit both is really similar. However, there's one point is the difference between that. What is that? Alluvial fan means that the open area, not the coast, not the sea, like not the ocean. However, the river or stream means that the ocean, like at the coastline, and then they're gonna lose their power to, and then at the drop at the deposit, we call it the delta deposit. So at the coastline, we are able to see the delta deposit easily. At the ground, but the low elevation area, but there is no ocean area, no coastline, but there is open space, and then with the lower level area, we are able to see the alluvial fan. So alluvial fan and delta deposit are really similar, but there is a difference. So Cameroon has a delta deposit. Cameroon, the coastline, Cameroon Parish, I mean. And we are in the wetland. That's why we cannot forget to talk about that the wetland. Wetland is different to the dry land. So there's commonly 4 types of wetland. One of them is bogs, and another one is banks. Third one is swamps, and last one is marsh. There's 4 different types of wetland we are able to see. Bogs. Well, they are peat accumulating pond with no outflow and little inflow. So they'll keep gaining that water, but there's no outflow. Just they're gonna keep accumulating. Not huge amounts of water sources, small amounts. They're gonna accumulate. So the bog receives a little calcium from the surrounding landscape and are therefore quite acidic. Okay? They can have a little calcium. So that types of like a pond, like a bog is what? Acidic. And fans are peat accumulating ponds with no outflow and little inflow. It's really similar to the bog. So bog and fan is really similar. However, what is the difference between the bogs and fans? Well, fan is calcium-rich mineral material. It means they're gonna get the what mineral from the little inflow, or their main soil material has a loss of the calcium. And what they have a what? Alkaline. They have alkaline. Because they have a loss of calcium. If there's small calcium, acid. So both and fan, both is similar, but what is the main difference between the bogs and fan is acidic and alkaline. Why they are acidic in the bog? Because there is a little calcium. Why fan has alkaline? Because they have a loss of calcium. Rich calcium means loss of calcium. And swamps are theoretically inundated with shallow and slow moving water and dominated by shrubs and trees. Marshes are theoretically inundated with shallow, slow moving water and dominated by grass and herbaceous plants. So swamp and marsh both similar, okay, both is similar. They're gonna have a slow moving water in the one swamp and marsh. However, what is the big difference between the swamp and marsh? That is the vegetation types. Okay. we are able to see that many of shrubs and trees like a water buffalo, or what is that the Louisiana tree, state tree? Bald cypress. We are able to find that the water buffalo and bald cypress in where? Swamp, and not the marsh. Marsh has what? Grass type or herbaceous types of plants. We are able to find it in the marsh, not the swamp. But they're really similar between them. So swamp and marsh, they are really similar. But one of the big difference between them is what? Vegetation. So you can see that commonly 4 types of wetland, and then you see that the main characteristic of each of them. Please note about that one because we are in the wetland. Am I too fast? You good? Fine? Okay? Can I keep going? Great. So here is the figure to show you how they're gonna move this broken piece of the sediment and accumulate it. Well, depends on that the slope. If you see, here is a deep slope. Okay, so commonly broken piece of the rock, the sediments or soil particles, they do not accumulate here. They're gonna rolling and move and accumulate here. And here's the stream or river. River gonna be moving. When the water gonna move it, they're able to carry that lots of the particle in a broken piece of rock. However, they do not only carry it, they also dig it and drop it. So right side, left side, both each side of the river, they're gonna drop some sediments to form the river bank in here. So alluvial is going to be occurred in here. Alluvial occurred in here. Colluvial occurred in here. Colluvial is what? All these sediments we move from the high elevation to the low elevation and then accumulate at the lower level area, elevation. So colluvial accumulate here. Alluvial is occurred in here, nearby to the water source. So we're gonna name it of each part. You don't have to worry about the previous slide. Mainly you need to consider about this figure instead of previous one. I think that you are able to find that this slide, PowerPoint slide in the board or text, the teaching material area. Okay. So please look at it, and if you cannot find this figure in the teaching material in the board, let me know. Okay. I will share with you about this. So commonly we call that residue material, a broken piece of rock that is located, accumulate, and the bedrock is in here. So bedrock breaking by physical or chemical action, and then broken piece of rock will accumulate here. Some of the broken piece of rock will be moved in and to the low elevation and accumulate that the sediment in here by gravity. Gravity. Nothing gonna affect it, just only gravity affected it. That's why a broken piece of rock is accumulated. And then here is a alluvial material that is accumulated by a river. So when the river moved in, they dropped it in sediments. Okay? And accumulate. So we call that alluvial occurred there, and we call this kind of area accumulated the sediments. Okay? By a river, and then that would be for the floodplain area. And then here is the slope, we call it shoulder, your shoulder area. And then drop it. And then here is the bank slope and here's the toe slope. Okay. I suggest you're going to remember that this figure about which area, how can you call that each of the area. Okay. How can you call that each of the area. There is a common the soil figures, soil slope area. Any question? You good? Well, we just summarized it. That's why some part I really do not clearly explain to you. So, however, if you cannot catch that, what's that? What I'm talking about it, and what, and then let me know. I'm ready to explain to you. I'm just gonna summarize it, what we learned before we start the soil fertility. That's why some part I skipped it, some parts a little confused. However, I think that is enough to wake you up what you learned it before. However, if you cannot catch it, if I use that not unclear the English, let me know. I'm able to ready to explain to you little detail. So in the soil forming process, there's a four soil forming factor in the previous slide. 5 soil forming factor. How about the soil forming process? Okay, process. There's a 4 soil forming process. Please keep in your mind. I strongly suggest you. There's a 5 soil forming factor and 4 soil forming process. So what is the soil forming process? There is addition, loss, transformation, and translocation. Okay? Whenever I ask you please list the soil forming process, some people say transportation, taxi, subway, ship, SHIP, or airplane. That is the transportation. There is no transportation here. Transformation, translocation. Okay. So first, addition. The broken piece of part will be moved by water, gravity, wind, or ice. So those broken piece of part will be moved by load factor from some other place to some area. Okay. So wind is going to blow up broken piece of rock and then drop in here. Ice is going to be moved and then with ice is going to move with the soil particle, and when the ice arrives in this area, the ice is going to melt down. When the ice melt down, they're going to drop the sediment. Some ice, big size of ice moved in, but when they moved it, they're going to tilt it up the bottom or side when they meet the soil. And then that part will be moved, the soil particle moved from the ice. Okay. Or water, when the water moved in, they're going to water past it and then they drop the sediments in here. Okay. So addition, soil particle or sediments going to be accumulate in some area. That was addition. However, when the ice, and then they're going to keep going, so that part will be moved to another place. So this area able to lose. Even wind is going to blow up that area, so wind is going to be able to carry out the sediments from here to another place. Water, same thing. When the water moves in or pass through this area, the water is able to carry out. Sorry about that. I just set up the outline because I don't want to bother your schedule. So let me finish this slide. This is today's last slide. So even ice stuck in here, they're gonna melt out, and then the water, ice will move to the water, and then move it to the low elevation by gravity. So when the water moves it, excuse me, they're gonna carry it. So this place also gain, addition, also they're gonna lose. Okay? So gain, addition, and loss will occur in that area. And when the sediments are going to be accumulating here, they're going to be able to move from the high elevation to the low elevation. So from that place, from the high elevation to the low elevation, because water can be moved from the high elevation and low elevation in the soil profile. When the water moved it from the high elevation to the low elevation, the water is able to carry out the sediments, mineral to the deeper area. So translocation is going to be occurred. Okay, translocation will occur in the soil profile. And chemical reaction able to affect that soil sediments or soil particle. That's why transformation going to be occurred by a chemical reaction, by a heat, by a pressure, and by a chemical reaction. Acids, alkaloids. They're going to be occurred to change their form. Simple concept. Lots of pure carbon put at a high pressure with a heat energy. And then the pure carbon transformed to the what? Diamond. Okay, joules. So that was one of the traditional example, transformation. Like transformer. Transformer change the car to the robot. Robot to the car. You're going to change it there from totally different characteristics. Same thing. The segments are going to be able to change their format. Okay? The atomic arrangements can be changed by some chemical reaction with a high temperature and high pressure. Transformation occurred. So when they changed it, the soil characteristic able to change it too. So you are able to see the four soil forming process: addition, loss, transformation, translocation. Okay. Well, I'm gonna stop in here, and then we have a lab on today. Today's lab is gonna be short, not too long. And so don't be scared on today's lab. See you in the lab. 2 o'clock, right? Bye-bye.